Hey, what is up? It is Sunday, April 24th, 2022, and I'm here to give you a new coding challenge and solve it. So welcome to Coding with Chef, where I do a lot of code and hope it helps somebody out. I don't have a good slogan yet, but that reminds me, I hope to get one at some point. So, anyway. By the way, before I get started with this new problem, which is a medium, uh, I'd like you to like this video, subscribe, and leave comments in the comment section below. Let me know how I'm doing, and if you have any other feedback, I'd be glad to take it into consideration and see what I can do about making this channel skyrocket. Anyway, so here's my problem that I'm tackling today. 1396 design underground system. Okay, well, that's an interesting one. I'm not a huge fan of the design this, design that problem, and I think that's mostly because of my own personal quirks about solving these kinds of problems, but they're important to know how to solve. So let's get to it. It's medium, it's really well liked, and I'm gonna like it too. And so all the code that I'm doing is my own. I have a discussion thread where I work on the problem first, and then I go through how to solve it. And it's all on my Leeetcode, etc. So you can go through that and find out, refer to the code in more detail. Let's get started. An underground railway system is keeping track of customer travel times between different stations. They're using this data to calculate the average time it takes to travel from one station to another. Okay. Implement the underground system class. So this class has a function void check-in with an ID, a station name, and a time t. A customer with a card ID equal to ID checks in at the station name at time t. Okay, kind of rhymes, doesn't it? A customer that can only be checked into one place at a time. Checkout, a function called checkout. And the parameters are ID, station name, and another int t. So a customer with a card ID equal to ID checks out from the station name at time t. So you can check into a station, a certain station. You can check out of that station. Okay, at a certain amount of time afterwards. So double. Okay, another function is double get average time with the parameter list string start station, string string start station, string end station. Okay, so returns the average time it takes to travel from start station to end station. The average time is computed from all the previous traveling times from start station to end station that happened directly, meaning a check-in at the start station followed by a checkout from the end station. Okay, the time it takes to travel and directly is also bolded, so probably is important. The time it takes to travel from start station to end station may be different from the time it takes to travel from end station to start station. That's good to know, because we know that this is an asymmetric calculation, that we have to actually do the calculation for the mappings from start station to end station and from end station to start station, and count them differently in the scope of the test cases. There'll be at least one customer that has traveled from start station to end station before get average time is called. You may assume all calls to the check-in and check-out methods are consistent. If a customer checks in at time t and checks out at time t2, then T1 is less than T2. All events happen in chronological order. Okay, so that's a lot. Okay, but I think generally at this point we should all have the gist of what's going on. We're just accounting for average travel times between two stations, right? Now let's go through the example, then we'll talk about the, I guess, tricky aspects of the wording here. I mean, interesting thing is, this isn't, I don't think this is a tricky problem. It's hard to describe, but it's more of a problem where you have to be careful in how you account for things, I think. So let's just go through the example. So the example says underground system check-in, 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 check-out, check-out. Okay, so 3 check-ins followed by 2 check-outs. So you have check-in at 45, station Layton, time 3, I guess. Then we have a checkout of customer ID 32 at Paradise 8, and then another checkout check in at Leighton, and I guess you have a time 10. Okay. Then you have a checkout. Let's see. You have actually three checkouts. Okay, and then a call to get average time, and then I guess you can call get average time within any point in all of these check-ins and checkouts. Okay, so that's something important to keep in mind. And then you have checkouts from Waterloo Station for 45. So there's 45 customer ID. Remember, you have to tie. I think here you have to tie these customer IDs together. And so the person checked in at Leighton, checked out at Waterloo, and the difference in time was 12. And then the person checked in at Paradise, 32, checked in at Paradise and checked out at Cambridge, because 32 was a check-in and 32 was a checkout. And the station was Paradise of check-in, station was Cambridge of checkout, so it's 22 minus 8, right, for that particular trip. And then Leighton, customer 27 checked in at Leighton and checked out at Waterloo, and the time difference was 10. So here's the trick. There's trips from Leighton to there's multiple trips from Leighton to Waterloo, right? So we have to take the average of those two, okay, when we're doing a get average function. There's also and then there's one trip from Paradise to Cambridge. Okay, so basically, so from Paradise to Cambridge, the average time is going to be 22 minus okay, so 3 trips to Leighton, from Leighton to Waterloo, because town plus 12. Let's see, are there 3 trips from Leighton to Waterloo? I guess so. Leighton to Waterloo, then you have more here. Okay, more inputs. Okay, so this input is actually quite long. So yeah. Oh yeah. There's a lot of inputs. Okay, so then you have you have 3 trips from Leighton to Waterloo. Here, Leighton to Waterloo. So you have to take the average of these 3 trips, right? 3. So the average is the difference it took for the time for each trip for each customer. So you have. Okay, so here's the deal. Let's get to we conceptually are starting to get the picture here. Okay. Every customer can have it helps to write this down. Customer can have multiple trips associated with it. Okay. A start station end station pair can have multiple trips from multiple customers, and each direction has to be accounted separately. Okay, so the average of each pair is what over all customers is the final output for the get average time calls. Okay, so these 3 facts we have to take into account. Okay, so let me show you how I'm going to take this into account. First, I'm going to create some member variables here for this class, and they're going to be in the form of maps. I'll explain in a second why I'm using maps, but you can intuitively think why we would need maps. Okay, we are going to need to refer to customers multiple times, right? Via the IDs. Okay, so, and we're going to also have to refer and collect stations trips according to the start station and end station. Okay, so this is called desc map. Desc map I'll get into in a bit, but it's basically how many accounting for all the trips we need to take. We also have hash map and trip pairs. Integer, so integer pair string integer customer trip map. Okay, so this is all the trips for a particular customer from any pair of station, from any station, right? And the reason I'm using a pair here, okay, is because I could use a list, but I need an element for each customer. I need their essentially trip. I need their end destination associated with the time it took to get to that end destination. And you'll see where I need to use it, but that would be a pair of values. So this customer trip map would be like customer ID, and then it would be, let's represent a pair with these brackets. It'll be like Waterloo 23, and then another ID, let's call it 44 because the IDs are integers. Then Water Leonia 3. So again, so basically the customer ID and the trip it took, and remember there could be multiple, the same ID could be associated with multiple trips to Waterloo. So if this was ID 18, then there could be another 18 with a trip that goes from Waterloo to it goes to Waterloo in 2, and or there could be another customer, let's say 17, 18, it doesn't matter. What we need to know is that what we need to know is that the customer's trip to that point has to be accounted for along with the time. So these are the two variables I want. Okay, so I'm gonna initialize them. Dest map, new hash map. There's a lot less nesting in the initializations. Customer trip map equals new hash map. Okay. All right, so now let's work with each of these functions one by one. Okay, so first what I want to do is I want to initialize my dest map here, because I want to make sure Haynes key, this is the start station. I want to make sure that our data structure has the available elements allocated if it's not present, because right now we're going to put a new destination key, by key, into this destination map. Okay, station name, new hash map, string, list, integer. And okay, so we had already gone over why this is, or roughly. Now you'll see in action. I think it's easier to see its usage once you see how I'm using it in this check-in function. So pair. So now we're going to put our destination along with the trip time and call it a trip, and we're going to set it equal to a new pair, and that pair is going to be station name T. Okay, because now, as I said, the station name for our check-in is going to be the start of this new pair. I'm going to refer to this pair later on in the algorithm when I do the checkout, right? Because I need to subtract the checkout time from the check-in time to get the time for that trip, and then we'll average those later to get the average overall times. That's something to think about. Just why would I need to do that? And you can, it's the basic distance formula. So now I'm putting my trip in my customer ID map. Okay. So here's the thing. We know that okay, so there'll be a, we're going to just assume that right now we have a customer with a specific card ID, and we're going to record their transit time. Okay. And we're only going to record one instance of a customer's transit time, but we'll have multiple customers. That's why we need that list embedded. So now that's our check-in. Our checkout. Now this is where you need to, I think, follow what's happening here. I'm going to get the trip, because at this point when I'm checking out, I have obtained my trip for the particular station associated with that, with this end station. So because the customer ID is tying it all together, and the second variable here is the end time, and I'm calling this end station, okay, because that's what we're getting here. Customer, you'll see where trip map, then remove ID. Remove is a chief operation, and I don't need this taking up space in this map anymore. In trip time, and you'll see it come together right here, t minus trip that get value. So get value is the function for getting the second argument of the pair. I don't like it. In Kotlin, it's something like second, but in this case, it's dot get value. So, but once you get used to those semantics, pairs are pretty nifty to work with, and they have an advantage over lists because they allow you in Java to use mixed data. Okay. There's other ways of doing that, but this is the easiest, I think, for the case I need. So now we have our end station. Now we want to get our start station. And I renamed this parameter end station. Originally, this parameter was called station name. But for the purposes of this algorithm, I want to make this easy to understand. So I'm getting the key. So now the key is, again, this element of the pair. The first element, the name of the station, and the name of the start station. So now what I'm gonna do that get or default and station new hash map. This is a whopper, isn't it? It's part of its Java's verboseness, but still. String list, and this is where I'm going to. You'll see what's going on here. Okay. Now we have that going. Okay, now I'm going to get my list of trips, right? And next we're going to compute our trip time list. Okay, we've got on our list of trips, then we're going to create a trip time list. Goes to station, get or default, end station. All right, and new array list integer. Okay, end station, new array list integer. So this is the actual list, and I'm doing this because we might already have the list stored at some point. So we want to not necessarily create a new list, right? Unless it's already stored. We want to add that list to. We want to add to the existing list if it exists already. Okay, and that's what I'm doing here. Trip time list dot add trip time. So I'm adding my trip time list to my trip time to the trip time list, and then remember the trip time comes from the user calculation. Okay, so put end station trip time. So once I've updated the list, I will put it back in for the next time this list needs to be accessed. And in the final destination map, put start station and station. I know this is tricky, and a lot of it is, again, the verboseness of Java doesn't help, but this allows us to keep track of everything we need for all customers, for each trip, for each station pair. That's where the work comes into this problem. String. Now I'm going to get this average time. Start station. Okay. And now this is where we want to I'm going to get my destination map. Equals to station get end station. Okay. Now I'm getting my trip list again here, and this function is very straightforward because in this function I'm just calculating the average time, but I just need to make sure in this loop I do that for each item in the trip list for that particular station's pair. Okay, This is, again, this is going to take some time to absorb. But at least the goal of this function is pretty straightforward, right? I'm just taking the list of accumulated trip times for a particular start and end station pair, and I'm returning that total average, okay? And yeah, trip list dot size, okay. Trip list, okay. And that's the average, right? Because I take all the values of all the trip times for this particular start end station pair, and then I just average them by summing and then returning the total trip time divided by the size. Okay, so let's see if this works. Of course, there's going to be little errors here and there. I'll hope to minimize them. Okay, let's see. Of course, the real problems come in expected. Okay, string, hash map to station. What did I do wrong here? Of course. Let's try this again. 34, incompatible, put. It's here. We want to put the to station because that is, this is how we essentially create our pair. Okay, so now that was accepted. Great. Let's see what happens to the rest of it. There you go, accepted. And again, you can't really trust the time. I got this as high as 80% at one point, 87% speed. It's actually not the slowest if you think about it. There could probably be a more compact way of writing this, but this is basically an exercise in data structure organization, okay? And it's going to be very important for these class files. But anyway, so that's it. It's a medium problem was a daily challenge today. If you like this video, like, subscribe. I know it's long, but there's a lot to discuss here. And yeah, I'll see you around.